What if Earth veered out of its orbit and headed straight for the king of our solar system? Jupiter. We're not talking about two space rocks bumping into each other. We're talking about our planet plunging toward a gas giant with over 1,300 times Earth's volume and more than twice the mass of all the other planets combined. To grasp the scale of this disaster, consider this. Jupiter's famous Great Red Spot alone, a storm that has been raging for centuries, is so massive it could swallow Earth whole without missing a beat. Remember to subscribe to the channel so you don't miss out on weekly cosmic mysteries. Many people might picture this event like two billiard balls colliding in space, causing an instant impact and a massive explosion. But physics shows us something far more terrifying and destructive. The real nightmare wouldn't look like we think. It would begin millions of kilometers before Earth even touched Jupiter's atmosphere. As Earth began its approach to the gas giant's orbit, conditions on our planet would turn chaotic within days. The first major threat wouldn't be gravity, but Jupiter's monstrous magnetic field, 20,000 times more powerful than Earth's and reaching millions of kilometers into space. As we crossed through this magnetosphere, Earth would be bombarded by lethal amounts of trapped radiation. Charged particles traveling at nearly the speed of light would slam into our upper atmosphere. The immediate result would be the total destruction of every satellite in orbit, permanently knocking out global communications, navigation systems, and power grids. At the same time, the radiation would strip away the ozone layer, leaving the surface exposed to solar ultraviolet radiation and cosmic rays. In the sky, a terrifying spectacle would unfold worldwide. Global auroras so intense and bright that they would light up the night like daylight, all while slowly frying every electronic circuit on the face of the Earth. As the distance closed to just a few 100,000 kilometers, gravity's uneven pull across celestial bodies would become dangerously clear. Jupiter would pull much harder on the side of Earth facing it than on the far side. This difference is known as tidal force. At first, Earth would stretch, warping from a near-perfect sphere into an egg-like shape. The oceans would react first. Massive tidal waves, hundreds of meters high, would sweep across every coastline, swallowing entire cities in minutes. As we drew closer, Earth's crust itself wouldn't hold up under the structural stress. The planet's interior would heat up intensely due to internal friction from this constant warping, a process known as tidal heating. Tectonic plates would fracture on a massive scale. Thousands of volcanoes, both active and dormant, would erupt simultaneously across the globe. The atmosphere would fill with ash, sulfur, and toxic gases, blocking out sunlight and turning the surface into a magmatic hellscape. By this point, any life that had managed to survive would be wiped out. Next, Earth would cross a critical, irreversible physical boundary, the Roche limit. This limit is the minimum distance a celestial object can approach a more massive body without being torn apart by tidal forces. If you want to see what would happen if the Moon crossed this limit relative to Earth, be sure to check out this video. For Earth and Jupiter, this limit lies roughly 50,000 kilometers above the gas giant's cloud tops. Crossing this threshold, Earth's own gravity would no longer be strong enough to hold its rock together against Jupiter's relentless pull. The planet would literally shatter in midair. Instead of a solid sphere, Earth would turn into a thousands of kilometers long stream of magma, glowing rock, and debris, spiraling down into Jupiter's clouds. If part of Earth's mass managed to hold some cohesion as it entered Jupiter's upper atmosphere, the final scene would be apocalyptic. The entry speed would exceed 200,000 kilometers per hour due to immense gravitational acceleration. At that speed, Jupiter's atmosphere, composed mostly of hydrogen and helium, would act like a concrete wall. Extreme atmospheric friction would generate temperatures over 10,000 degrees Celsius, far hotter than the surface of the sun. Whatever ocean water hadn't evaporated yet, along with Earth's atmosphere, would instantly vanish. Mantle rock and core metals would vaporize, triggering a blinding flash of light visible from the opposite side of the solar system. However, due to the immense density and depth of Jupiter's atmosphere, there would be no crash onto a solid surface. Jupiter doesn't have a firm ground like Earth or Mars. It's a fluid abyss that grows denser the deeper you go, like a virtually endless ocean. Our planet's vaporized remains would continue sinking deep into the lower layers. Thousands of kilometers down, the atmospheric pressure reaches millions of times that of Earth's surface, so extreme that hydrogen ceases to be a gas and behaves like a liquid, electrically conductive metal. In this incomprehensibly hot, dense environment, the atoms that once formed Earth would completely dissolve. Heavy elements like iron and nickel from our core would slowly sink for decades until reaching Jupiter's dense central core, trapped there forever. In a matter of hours, the event would be over. No trace of Earth would remain on the astronomical map. Jupiter, for its part, would gain a negligible fraction of mass, just about 0.3% more than its original state. The complex, endless cloud bands of its atmosphere would close over the entry point, erasing all scars within days or weeks. The Great Red Spot would keep spinning serenely as if nothing had ever happened. Let us know in the comments if you'd like to learn more about that mysterious red spot on Jupiter. Hopefully our orbit never crosses paths with Jupiter's, as an event like this would quite literally wipe us off the cosmic map. Thanks for watching until the end. If you enjoyed this video, don't forget to like, subscribe, and comment on what other catastrophic space experiments you'd like to see next.